Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So in this specific discussion, we're going to look at the concept of a product of simple binomials. And this is going to be in terms of a problem set. So I've just given one of the examples of a binomial on the board. And this is going to assist us try to find a general representation or a general way in which we can be able to solve such kind of problem sets. So in this case, I'm going to borrow from our first discussion we had on polynomials and different operations with the polynomials. And in this case, I'm going to mention, of course, that basically for us to find a product of polynomials, we used to do multiplication using specific rules. And of course, in this case for binomials, we are going to use a slightly different set of rules, which are going to assist us, of course, come up with solutions of simple binomials. And in our different discussions, I mentioned that basically the concept of binomials is going to consist of expressions which consist of two terms. And if we consider in this specific case, we have a coefficient of 3 and this specific letter which has been given. And of course, I've mentioned the concept of unknowns in expressing different parts of an expression. Therefore, we have 3 and unknown A, which basically we said A and B consist of a set of real numbers. So in this case, if we have 3 and A, therefore 3A is going to form our first term, and then negative 2B is going to form our second term in this specific case. So the operation we require to perform in this specific binomial is a product. So quickly, we are going to remind ourselves about specific rules which we need to adhere to in order for us to solve binomials. And this is going to be in terms of the general expression given for A plus B. And this is going to form a general case for, of course, our binomials of this specific kind. So therefore, we're going to have to remind ourselves of the various, of course, ways in which we have expressed this specific square of a binomial, whereby we have said that we're going to expand this and have it in terms of A plus B and then A plus B given as such. So this is going to entail this specific first and second term being given separate, of course, cases or another separate sets as such. And we're going to multiply this specific binomials using slightly different rules, as we said. So therefore, for us to obtain the product of the sum of these two specific polynomials, we're going to find the product by multiplying together only one term from each of these specific sets to the second and the third term in this specific case. So I'm going to elaborate on this. So therefore, we need to perform a multiplication of this first term of this set of a binomial by the first term of the second, and then the second term of the second with this first. And then we'll also perform an operation which is going to go in that respective order by multiplying the second term with the first and the second term respectively. So the sum of the two products which are going to be obtained are going to form, of course, an evaluation of this specific binomial. So therefore, we are going to have a square of A, that is A times A times B, so this is going to be plus AB. And then for this second term, we're going to have A times B, which is going to form AB, and then plus A times B is going to form a square of B. So we can simplify this specific expression by giving the like terms, where we're going to have the square of A plus. So this AB, 2AB plus the square of B. So if we try to look at this specific expression, therefore it's going to form a specific product, which we can be able to describe in a characteristic way. So this is a square of a binomial gives us the square of the first term. We put it in simple ways as such. So this is going to give us the square of the first term. This is our first observation, and then we're going to see that it's going to give us the cross product over the first and second term. So this is going to be unique in a way that this particular cross product is going to be twice the cross product of the first and the second term, as we can see. And then we're going to see that again, this is going to give us the square of the second term. So therefore, our evaluation is going to consist of an answer which consists of the first term as the square of the first term, and then plus the cross product of the first and the second term, which is going to be twice. So that implies that it is twice the cross product of the first and the second term. And then lastly, we are going to see that it's the square of the second term given in that specific order. So binomial expressions of this specific nature are going to be having, of course, answers expressed in that specific format. So therefore, we can be able to do our evaluation of this example I've given on the board and see whether it's basically going to follow this specific order. So this is going to be 3a minus 2b. So we can do an evaluation, and this is 3a minus 2b. We've said that we're going to do a square of this one. So therefore, we'll be taking note, of course, of the difference which appears or appear in between, and see what are some of the differences we're going to obtain. So this is going to be 3a and 3a. So we take the first term and multiply with the specific terms of this other, of course, part of the expression. So we're going to obtain the square of 3, which is 9a. Sorry for that, 9a squared. And then this is 3a times negative 2b. This is going to be 6ab. And then this is negative 2a times 3a. And then, so this is going to be still minus 6ab. And then minus 2b times minus 2b. This is going to be a sum over 4b squared. So if we try to evaluate this one and perhaps try to reduce it or simplify it in that specific order, we're going to find this is 9a squared minus 12ab plus 4a squared. So let's see whether this specific answer is going to follow this particular trend we are given for the general multiplication of our binomials. So is the first term the square of the first terms of this specific expression? So we're going to see the square of the first term is 3a. So its square is going to be expressed as 9a squared. So this first condition is correct. So the second one is that it is twice the cross product of the first and the second term. So the first term is 3a minus 2b is the second term. So the cross product of the two is 6. It's going to be minus 6ab. Since we have this minus sign, so it's going to be a negative. This is 3a times negative 2b. So this is going to be negative 6ab. So we have said it is twice. So this one implies that it's negative 12ab. So this is negative 12ab, which is twice the cross product of the first and the second term. So the second condition as well is okay. And then lastly, we say that it is the square of the second term, which is going to form our last part of this specific answer. So we are going to see that the square of the second term is negative 2b squared is equivalent to 4b squared given as such, which is our last. So this, sorry for this. So this is supposed to be b, the square of b, which is this. So it's going to be 4b squared given as such. So this basically is going to be the rule we are going to, of course, be applying in trying to multiply or find the product of a simple binomials. And in our next video, we're going to, of course, look at an example of the square or perhaps what we refer to as the cube of a binomial and see the difference between the two. And perhaps the general rule which is going to apply, which consists of these specific conditions which we can exploit to find answers to, of course, expressions of this similar kind. So that is it for now, guys. Bye. God bless you. Catch us in our next video.